Hi everybody, my name is Bailey Siegel and I'm a senior in the MST Magnet program. This is normally a time in the symposium where I would shake your hand, ask you a little bit about yourself, but due to COVID-19 that is no longer plausible. So we're just going to jump straight into my project.
Also, just a quick note before we get started, you may have noticed by now, but I'm not going to have my research poster visible at all times throughout this video. You can pause and look at it here, and it's also at the end of my video. Aside from that, you can also access my research paper via the QR code on my poster. Let's get started. I spent the summer in Boston as part of MIT's Beaverworks Summer Institute of Technology. I worked specifically on a project linked closely to MIT's Lincoln Laboratories on remote sensing for disaster response and relief.
We are fortunate in Washington State not to be prone to many natural disasters, but this doesn't mean that they don't occur. Ever since 1973, when ad hoc legislation was replaced by HUD, later replaced by FEMA, when a natural disaster occurs, the government gets involved. Sadly, aside from the consolidation of agencies, not much else has changed for disaster response. The current surveying and identification methods include individuals going from door to door with paper and spray paint. This is labor intensive and often puts more individuals at risk, as well as the information is not immediately communicative to external sources. This has vast amounts of problems associated with it and leads directly into my project.
Recently, Lincoln Labs, in partner with MIT, has been developing ways to use remote sensing and GIS to assess factors during a crisis. These methods can manage large amounts of data quickly and can be used to accurately assess regional responsibility without sending more people into danger. From January to April, I completed several online edX courses in order to apply BWSI. Then, throughout my 4 weeks at MIT, I attended lectures, seminars, field trips, and participated in projects to enhance my coding skills and learn about disaster response and relief.
For our final project, the 15 members of my group and I wrote algorithms to provide actionable recommendations for a hurricane simulation provided by our instructor. We were separated into several groups. I was part of the public relations group, which, yes, still involved quite a bit of coding, and I was also the sole individual responsible for flooding and evacuation.
For the purposes of the simulation, a mounted Google Colab provided a geospatial Shapely file indicating guaranteed flooding for a tropical storm.
I used this as a base and determined that at a level 5, the hurricane would not buffer more than 10 miles. I created a second Shapely file by buffering the first to 10 miles and using a GeoPandas spatial join to create a second GeoPandas data frame. By querying the data and subcategorizing before determining the 95th percentile based on elevation, I was able to create a rudimentary flood progression map. I then converted the geospatial Shapely files CRS from EPSG 3857 to the World Geodetic Coordinate System with EPSG 4326 to produce the maps you've been seeing. Next, I took this information and began to assess evacuation regions. Based on information given to us by our advisors, no more than 600,000 individuals could be evacuated per 24 hours, and out of these individuals, only 85% of them would heed evacuation warnings. Lastly, no individual should be evacuating at the time that the hurricane makes landfall for fear of creating more at-risk populations. Using my worst case possible flood map, I used compound queries, buffering, and loops to create geospatial Shapely files for each wave of necessary evacuation. At each 24-hour mark, one round of simulation, another round of evacuation would occur, assuming that the evacuation number was not higher than the hurricane severity number and that the hurricane was not within 1,600 kilometers of landfall. During the actual simulation day, I was responsible for communicating between the teams, taking the data provided by each algorithm and using matplotlib functions and a simple geodata frame to convert it to a readable form. On our initial simulation run through, the evacuation code resulted in a segmented geodata frame, meaning that only the largest fraction of the population was evacuated. Because the more geographically isolated populations were not evacuated, we ended up with a death toll of over 1,000 individuals. But after several hours of me coding, my computer running out of RAM, frustrating, and me literally dreaming in code, I was able to fix it and get the death toll down to 117 individuals, which me and my instructors consider to be a massive success. Lastly, since this is it, I just wanted to take a minute and say thank you to the Magnet program and for especially whoever's listening to this video, but for all of these research opportunities, this amazing program, and for making me the person I am today. Bye! This is Bailey Siegel signing out!